In this problem, you will use an exponential model to solve a problem. The best temperature to brew coffee is in between 195 and 205 degrees Fahrenheit. Coffee is cool enough to drink at 185 degrees Fahrenheit. The table shows temperature readings from a sample cup of coffee. How long does it take for a cup of coffee to be cool enough to drink? Use an exponential model.
What we know from the given. So we have a set of values and best serving temperature. What we need. Time it takes for a cup of coffee to become cool enough to drink. And what is our plan? Use an exponential model to find the time it takes for coffee to reach 185 degrees Fahrenheit. Step 1. Plot the data to determine if an exponential model is realistic. Why does it make sense that the graph of this data would have an asymptote? So the temperature of the hot coffee will get closer and closer to room temperature as it cools, but it cannot cool below room temperature. Step 2. The graphing calculator exponential model assumes that asymptote is y equals 0. Since room temperature is about 68 degrees Fahrenheit, subtract from each temperature value. Calculate the third list by letting L3 equals L2 minus 68. The graphing calculator exponential model assumes that asymptote is y equals 0. Step 3. Use function that transfer data to find an exponential model. And step 4. Translate y equals 134.5 times 0.956 to the x power vertically by 68 units to model the original data. Use the model y equals 134.5 times 0.956 to the x power plus 68 to find how long it takes the coffee to cool to be 185 degrees Fahrenheit. So the coffee takes about 3.1 minutes to cool to 185 degrees Fahrenheit.
Problem, you will evaluate e to the x power. How can you use a graphing calculator to evaluate e cubed?
We have three methods to answer this question. With the use of your graphing calculator from method 1, you will use the key e to the x power. After you press e to the x power key, what keys should you press? Since the fourth question. How can you use a graphing calculator to evaluate e to the 8th power? E to the 8th power is approximately 2,980.957987. You can use three methods. For number 1, use the e to the x power key with x equals 8. For method 2, graph y equals e to the x power and find y for x equals 8. And for method 3, use a table of values for y equals e to the x power and find y for x equals 8.
In this problem, you will calculate continuously compounded interest. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. First, write the formula for continuously compounded interest. What is the unknown? The unknown is the amount A in the account after 4 years. Substitute values for P, R, and T. Now simplify. Use a calculator. Round to the nearest dollar. The amount in the account after 4 years to the nearest dollar is $3,664. Now grid your answer, 3,664.
Got number 5 question. Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. How much will you have in the account after 4 years of high school? Express the answer to the nearest dollar. First step, write the formula for continuously compound interest. We have A equals P times T raised to R times T. Then, substitute values for P, R, and T. P stands for principal, R stands for rate, and T stands for time. So we have A equals 3,000 times E raised to the power of 0.05 times 8. A equals 3,000 times E raised to 0.4. Then simplify. So it means A equals to 4,475. The amount in the account to the nearest dollar is approximately $4,475. Thank you for listening. If you have any questions, just send it through Schoology. Have a good day.